Okay, so welcome now members. We are going to see now how do we get that volume for solids of revolution. Now, please don't forget to subscribe to the channel. Now, to get the volume for solids of revolution, we are going to consider a function or a curve f of x defined on the interval from a to b on the x-axis and then on our Cartesian axis like this. Now, if I have this as my f of y, now to get the volume, I'll divide this from here up here. I'll divide into small strips or small elements, or some people call them coordinates and so on. So I'll divide them into small strips. So if the height from here of this one strip from here to here up to this curve is y, and it has this, they are very small at its width, they are rectangular strips of its width, delta x, the width of this is delta x. Now, it means that now, if I rotate this strip like this, that if I rotate it, it will form something like a cylinder, very small. So, if I pick out this one strip, remember they are many, so I'm just concentrating on one. If I pick out this one strip and I put it here, so that this will be, from here up to here, it will be the radius of that strip. So, from here up to here, it's from here up here. So this is the point where it starts from this point here. So from here up to here is the radius, which is y, and from here up to here, this is the height, which is delta x. In that volume of a cylinder, so now this is the cylinder, but it is a small cylinder. When I increase its size, I think you can see that it's going to be a cylinder. So it's a compressed cylinder, and that the volume of a cylinder is always pi r squared h. So from here, start my r, the radius is y, then my height is delta x. So, putting them here now, the volume of this small strip, that's why I'm calling it a B1, the volume of one strip. So, it's going to be now y squared, then h is this delta x there. So, volume of now all the discs or elements or strips, or the independence of the element which you give them, from x equaling to f, x equaling to b, meaning if this strip is having this as its volume, it means that to get the volume of the strips from here up to here, I will sum the strips from A, the volume of those strips from A up to B. This one means that you sum the volume of those small strips. So I'll be having the volume now of this strip from here up to here. So now, this is what I'm having here. So as delta x tends to 0, it means that now the volume will be now, this one tends from being small change now to capital D. So it becomes delta x. From here now, not summing from A to B, the same as integrating from A to B. Now this is the formula for volume of a solid, which is rotated about the x-axis, so that we are rotating it about the x-axis. Now, similarly, you can get the volume of a function f of y rotated about the y-axis in this form. This is the y. This is delta y. Delta y, like that. Now, generally, if the curve is rotated through theta degrees, then this is how you can get the angle. This is how you can get the volume of that curve. Get theta divided by 360 pi of this. Remember now, if the angle of rotation, where theta is the angle of rotation, so here I rotate this from here up the other side. So the angle of rotation here is always 360 degrees. That's why if your angle of rotation is 360 degrees, you will put here your theta as 360, you come back to this, because this will be 1. So the volume between two curves or two functions, so we can get that volume. You get now, if this the curve up minus the curve down, but you get their square. So if I want to get a volume between these two curves, from this point, assume this is my A, and that's their point of intersection. These are their points of intersection. Then I will get from A to B, then the square of this curve minus the square of the curve down. So upper curve minus the downer curve, then dx if they are about the x-axis. So members, that's the introduction to solids of revolution, the volume of solids of revolution. Wait now for examples and you see how we handle them. Don't forget to subscribe to the channel. I wish you the best.